record on this computer. Okay, we're recording now, and there are other people here. Feel free to ask questions. I will be within earshot after I go back and get my stuff. We'll be back in a second.
For recording sakes, I'm just gonna.
You can stop recording or start recording.
No, yeah, I'm just gonna explain
Okay.
setting up on a personal computer.
Okay, that's good.
So, to use the Bantam PCB machine, you likely either need to bring in your own laptop with the software pre-installed, or you will need to figure out how to nag one of the IT admins to add Bantam to all the other users of the nice computer right here. So either which way, you need to download the Bantam software for it to work. Once you plug it into your computer, it's pretty much pre-configured. You don't need to change any settings. You're going to get a screen that says home machine because it doesn't know where its XYZ is because we just reset it. So you want to start the homing process. That's pretty much just steps to get it started. So start moving around. The tools to remove the bits are up at the very top. They're magnetized to the machine. You need both of them. They're different sizes. You can just wait for it to really.
No, it's doing something.
Yeah.
Sounds like the 3D printer when it's working.
It's going to hit its kill switches and then it knows.
Yeah, it's finding a zero spot, right?
Look at all the copper down there.
I don't know.
Oh, is that what you're
I figured out
vacuuming
how
out?
to
That's what I was vacuuming.
Okay.
If I press down on the thing,
So
I stop.
the way this PCB also works is there's 4 different plastic shields. If you do not have the shields on, it will not start the print. So do not misplace these because then no one can print.
Unless you 3D print some more.
Like it's yelling at me now that the safety cover is open.
Hi, are we supposed to see what you're doing or?
Hey,
You can, yeah, you
Not
can.
bad idea.
I got it. Or unless, does that work? Yeah, that works.
Yeah, thank you.
All good. So the machine, once it's homed, is going to sit in a specific position. Don't try and move anything. Anytime you need to move it, it's through the software. So if you go to, or when you open up the software, you get a few options right away. Just go to the initial setup page. And when you go to initial setup, you'll pretty much, okay, why is my 20 freaking out? You pretty much have to open up a file. Now, when you are working on uploading these files, there is specific files it will take. It will take a .board file, a .gtl file, a .gerber file, a .cmp file, a .gcode file, a .nc file, a .tap file, a .svg file, or a Bantam plan file, which you would have previously set up. So most of these cases, you're going to have a board file because you would have created the board. If your software doesn't create a compatible file, you should be able to export your board through the, I believe it's through CAM, right? Yeah, so you use the CAM processor to export your board to a Gerber file. Now here's a catch-22. When you use the board file, it comes with all of the details with it. If you're using a Gerber file, it will only have the traces, so you need to make sure you also download your N path and your P path for your drills. Otherwise, you're just going to get the traces, and any of your through holes will not be a through hole. It'll be solid. So just a little note on Gerber files. So pretty much,
You have to drill them by hand.
yeah.
Yeah.
Or you could rerun it with just the path file as long as you don't pull up the PCB.
Right, because otherwise the alignment would be off.
Yeah, once you pull it off the pad, because you got to tape it down, it's pretty much out of alignment and you are done. Like you can't put it back in because it's not going to know. So from there, you pretty much see, I'm going to unplug it so that you guys can see. There are, computerception here, a few different milling tools. And what that does is that allows you to change the occlusion of these spots. I know it's hard to see, but there's a lot of red traces on my computer, and that's because I only have a 1/32 flat end mill chosen, and red means that it's gonna destroy the path with that size of a bit. So the system lets you pick 3 pre-configured bits to do the entire thing, and every time it switches, it'll stop, it'll wait for you to do it, and you have to press OK. I recommend always using a PCB engraver a flat end mill for your through holes and a ball end mill for your traces because it's a really fine end and it worked really well for my capstone. So let me just select those few bits. So speaking of bits, there are a few boxes in the cage. These gray ended ones are all flat end mills. We have everything from 1/8 to 1/32 to 1/64. I don't know where the 1/16 is. I think it broke. We have about 6 different PCB engraving sets. We only have the 0.005. Everything's labeled though, so you should know. And then we have 3 1/32 ball and mills. Again, those are just kind of the most used pieces and they're the easiest to help. So let's set the PCB to 0.005 inch PCB engraving. That gives you a bunch of red lines. Then you add the, what is it, a 1/32 ball and mill? Well, there is no 1/32 ball and mill, so we're gonna have to figure that out. So for the meantime, we'll do 1/32 flat end. Where did that go? That's too big. What about 1/64? You pretty much just play with these settings until all of your traces are no longer red. Red just means that something's going to get screwed up and you're wasting your time. So yeah, you just play with that until you find something.
I took one Saturday. You got me the result back like the next day.
Yeah, mine was, I took it Thursday and I got it Friday or Saturday. So.
I got on Wednesday last week. Got mine Monday. It turns out I have double COVID.
Okay, so this is going to take me a minute to figure it out. So if you guys have any questions, feel free to ask.
Well, you know, double COVID is 2 negatives and they cancel out any positives. So we're
Okay.
fine.
Yeah, oh, there you go.
But it's like electron negatives. We're actually dealing with positives here. Yeah.
Electronegativity draws COVID towards you.
Probably
Okay, this looks funky. I'm missing a bunch of stuff. So if I get rid of the 1/32 flat.
There was a question in the chat about software.
Okay, I'll hop into the chat.
So you can
Yeah.
make the software in whatever.
That's a good idea.
Or sorry, you can make the boards in whatever software you want. So
Monitoring chat while you're talking.
Bantam is the most compatible with Eagle files and KiCad files. They both use .board. They're pretty much compatible with each other, but those are going to be like your easiest transfer because those you can use the board file. I know Altium, I want to say, gives you a .gtl file.
Okay.
But again, no matter what software you're using, as long as you can export it to a Gerber file and that your NPath and PPath holes, you're fine to use whatever software you want. Now, why is this acting so?
That's what Max uses. He's a pro. Yeah, he's doing too simple. He's using Altium. I thought he used TCAT for a reason. It's free. You have to pay for it. I think he already had Altium beforehand. He said he paid for it.
Okay, turns out if you're using your own computer, you will need to create your own 1/32 ball and mill. It may seem like a lot, but there's already a 1/16 ball and mill, and you should be able to just copy it over and shrink the dimensions by half, and it will be set. So let me just finish doing this. Sorry about the delay, everyone.
I heard someone say something in chat, but my chat didn't get it.
No, Discord.
That was Discord.
Yeah, not my Discord.
Okay.
Julie's Discord. Does Julie have Discord?
Yes, I do.
You do? She does
Yeah.
now.
No. In INF 639 last semester, it was me and Jack and Nigel and Cameron all on Discord in the middle of class. And we'd like be shooting questions back and forth at each other, or telling jokes to each other.
I wasn't invited.
And Julie, are you going to attend 639 next semester?
I don't know. We'll see.
Because I am still enrolled in that.
Yeah.
Cryptography, I think was too much for me, but
Yeah, you got, the nanotechnology is a little less mathy, so
Yeah,
a little more
it's-
hardware oriented. I don't know if Bertrand will let me loose in front of the programmers again. The one lecture you let me do on hardware, I guess I scared the programmers. Some of them wanted to drop the class. It was like all of electrical engineering in 2 hours. 110 to 110 to 490 in 2 hours.
Can I get that lecture? Thanks.
I remember that. I didn't find it too difficult, but that's probably because it's my major.
Yes.
What would be the diameter of millimeters of a 132nd? Time for conversion.
2.54 centimeters per inch, and then you go
30 seconds.
a 32nd of that. And, yeah.
0.794. 0.79375. Oh, hey, it already hit 132nd. Nice. Flute length. Okay, now that's an important question. There should be a pair of dial calipers somewhere around here.
Who's last? One is this one, the other Joker.
Oh, we do need those dial calipers. Otherwise,
Yeah.
yeah, I thought that was the jack. So
Yeah, see, that's the advantage. It's cheaty, but I do it because of the PCB Demo.
Right here. Found them.
hey guys, I miss Sharper's old Yu-Gi-Oh poster that used to be hanging back there.
We were supposed to put it in your living room.
Where'd it go?
Save it.
Where'd it go?
Might be in that box.
I don't think Severing House had the same
If
thoughts.
you find it, it goes in the IEEE room.
I put Ricardo's stuff as well.
Oh, good. Ricardo's the one that found that, yeah, she's taking the microwave.
4.5 millimeters of the flute. Number of flutes is only one.
Why does that matter?
Is the
Because it needs to know how far down it can go.
firmware finished up
So-
there, Hugo?
What?
Is the firmware finished up there?
It was like a minute. So when you're creating your 132nd file in mill, it looks like the settings are going to be, you say it's a flat end mill under the type because that's the only real choice you have besides engraving bit, and it's not an engraving bit. Your diameter is 0.79 millimeters. Your flute length is 4.5 millimeters. And your number of flutes is, I would just leave it as 0. Right?
If it doesn't have any flutes. then
I've
zero.
never had to change these settings like
Okay.
this. Speeds and feeds, I would not touch.
Yeah.
If you want to go quicker, you're very likely to snap the bit in half.
Yeah.
And it's a pain. What?
I'm not sure Alan.
Yeah.
Or you,
Alan puts all his printers and stuff at like 200% and tightens up he tightens up
That upsets me so much.
the belts and stuff. He
Yeah.
tightens them until they're like basically white. And I was like, oh, you just paint over that. It's like some black paint. And then you don't have to worry about the rubber stretching out, losing its color.
the color is the important part, isn't it?
Uh-huh. It upsets me so much when Alan talks about that kind of stuff.
Okay. So for the sakes of this exercise, my computer, my traces are off by just a hair. So 0.005 isn't going to cut it. I need to switch it to the 0.003. Pretty much what I'm going to do is I'm going to trick the printer, which I don't suggest doing because you're likely to run into issues. I'm just doing it so that I can show you guys how something prints.
I forgot that
So
I was thinking.
Please note that.
One as a 1 and one as an 11. Yeah, I guess my
What do you have a bunch of? It's been 132nd.
flat end mills.
Have you ever seen the Red Green Show?
Huh?
The Red Green Show?
Red Green Show.
Okay. So you play with your milling tools until you find the correct 3. You're only allowed 3 that will not cause any red. Once you set that, it will pretty much have the rest of it set. So that's it for milling tools at least. Next, you got to go to. Hold on, I unplugged the machine. Sorry.
Yeah.
So when you're going in order of the setup, it's going to ask you for a file, and then it's going to ask you to install the tool. When you go to install tool, you just click the button. The printer is going to move itself to the proper position. That's when these 2 little bits come into place. So now it's going to ask you, what tool are you trying to install? I'm going to start off with the PCB engraving bit, just because we can start there. Okay. I actually screwed this up already. So when you go to install tool, don't select the tool until you've switched the tool. So this is kind of hard to see on camera. I don't know if you guys
Here,
want to.
I can point my front camera
Okay.
closer.
So there's 2 spots you have to hit these wrenches, and they both go in at the same time, because pretty much what happens is you have to countersink it without, I don't know, it just works.
It just works. Let's see here.
Because you need the chuck loosened, but you don't want to loosen the thing that holds the chuck.
Correct. So you take the smaller one, put it in this little slot. Bigger one goes on the bottom, and you push apart to loosen. And once it's loosened, you can pretty much just hold it by hand and loosen it the rest of the way. The bit should pull out. Now, something that whoever set this up last did wrong is this little fan goes on the end of your bit. It looks ridiculous, but it blows all the shavings off your PCB, and it does save it from causing imperfections. Now, I have no idea which tool this is. We'll figure that out in a minute. Can you hand me the PCB engraver? It should be, I think.
Which size? This is the.
They're all the same size.
Oh.
Not metal engraving, PCB.
Oh, sorry.
No, you're good. So, how you install bits is you take them out of their case.
One metal engraving.
Usually, I try to keep the case on the machine when the bit's in it, so someone knows what kind of bit is inside of it, because there's so many. So please
Yes.
try to keep it clear.
Yeah. Otherwise, you have to go through and see which one's missing, and hopefully it matches up.
Yep. Okay, so you pull the end off. Again, the end can just go in the case. Your little fan, the flat end goes up, the fan side goes down. You just kind of push it until it's snug. And then you take the whole thing.
Can all of you guys that are online see what the footage that I'm getting off my phone? Is anyone still alive there?
Oh, yeah.
Yeah, we can see it.
Cool.
As a side note, these PCB engraving bits are really sharp. I already poked myself, and I think cut myself. So just careful. Like I said earlier, there's a bunch of different plastic shields on it. There's 2 right here that pop off. The one you may not notice, there's one in the back. That's got to be on. And then the front one.
Please do not bleed all over the PCB machine.
Yeah.
So anyways, you don't need it on until you start. So once you have the proper tool in, you go in. Like, I hate this. My computer is not good with this printer. You select the correct bit. Like I said, in my case, I'm tricking it. Don't do what I'm doing. You go next. Okay. So it says verify that the tool is above an empty spot on the bed and move the tool as needed. So what that pretty much means is when you look right here at the tip of the tool, if it's not over an empty area of the bed, because usually you might already have a PCB tape down here. So like, again, if you have a PCB tape down, when you're homing this, you cannot have the PCB in the way because it needs to touch the actual metal plate.
Mhm.
So once it's above that, you tell it start. It'll go down, touch off in progress. That's all it does. It just needs to know how far down to go. So once you have that done, now you're into program settings. If you want to use inches, feel free. All of the tooling and stuff here is in millimeters, so I recommend leaving it in millimeters, honestly. I've never played with these settings. These are all new to me, so I'm just going to close the program. So why are you in settings? Okay, so now we have the tool installed. We have our board selected. There's no more red traces. You have all the tools. You're telling it you're milling in the top, traces, outline, or traces holes. I don't want the outline done, so I turned it off. Now you get a material setup. This is where you take a one-sided PCB out of the big old PCB bag.
Fucking plastic.
Yay.
Are they individually wrapped?
Yes,
Sorry
and
if I
plastic, but,
Right, if I open this.
yeah, go ahead. Yeah.
So you just need, oh, these are double-sided, not one-sided. Okay. So, I'm just going to use a double-sided PCB. That way, if someone wants to finish the other side of this, they can. I'm not going to be mad. Anyways, so step number 2, you got to measure this thing. So you grab your dial calipers and you get the remeasurement. It's going to sit like this, so long sideways. So
Start recording and I decided I'm gonna put it on my YouTube channel.
okay, good.
It's easy to find. You just go to YouTube and search for
About
Jiggly.
126.9.
Okay.
So
Yeah.
I also have a
I believe that way, yeah. So this one.
I'm hoping the recording turns out well enough, recording from like two different like viewpoints here.
Mhm.
The Y is going to be
It's called monkey cage.
101.6.
Alan told me a cage monkey the other day, and I didn't appreciate it.
Oh, we used to call this the cage and keep sharpeners.
So those two, the X and Y measurements aren't that special.
Hey,
The Y one is the most important
Now it's the
one
cage
because
we
if
keep
you
under
get the thickness of this wrong, you're either going to not touch it at all and you're going to waste a bunch of time with the tool going over nothing, or you're going to put the tool straight through it and it's going to snap the second it tries moving laterally.
Right.
So please make sure that you're taking the thickness of this very
accurate.
accurately. Material size, okay. So yeah, the thickness of this, I do 0.
We're also playing blackjack over there if you want to go.
So the thickness of this is 1.60. So just make sure that you have that in there properly. Then you go next. Come on. So now it's going to ask you for the material placement and the material offset. The material offset is going to be how thick the tape is underneath your board. That sounds insane. How thick the tape is that tapes it down.
Yeah.
So
That will
even
affect the thickness enough that you're not gonna get a good drill, or
If-
you're gonna drill too deep.
yeah, pretty much without the added tape thickness, you're again just going to put the drill bit right into the copper and it's going to snap the second it moves. So there's very specific double-sided tape in the lab. I think this might be it. Yeah, this is it. So it's nothing too special. You just kind of slap a few pieces on there. Call it a day.
Can't have tape bubbles.
Yes, no tape.
Right, because they're thick.
So I believe 2 is the minimum, just one on each side. If you want to be extra safe, feel free to put one in the middle. Kind of a pain to get up, to be honest. So once you have that done, okay. So you know that your material thickness was 1.6. When I measure it with the tape, I get a thickness of 1.95. So the material offset is another 0.35.
Right.
Come on. 0.35. Probably lets you determine the exact. Interesting. Okay, so apparently there's a new button that lets you just click it and it automatically does all this calculations.
Figures out how thick it is.
Didn't know that. That wasn't like that a while ago.
Updates.
Anyways, so your material offset, your X and Y, is pretty much asking how far in the X and the Y direction you want to move this in. Now it's always expecting you to place it on the front left spoil board. When you start getting into more complex things, I would recommend reading the manual, but there's a bunch of different framing and stuff for precision alignment, especially on the double-sided, so that you can get it in the same spot.
Right.
But I haven't gone that far, so just read the manual and take caution. So, you peel your teeth.
It's ruined.
So we're going to go, I believe, next for now.
Does this have, is this like a manual? We just lost someone else. Bantam Tools desktop. Okay, looks like a
Yeah.
manual.
So next it's going to ask you for the plan offset. Hold on, I'm gonna do something out of the way real quick. I'm gonna press jog and then go to loading. When you go to loading, that's how you put the copper on and off. I'm just kind of skipping around some steps so that I can put this on. But again, you want to make sure that you line it up perfectly with the top plate's left edge and face edge. Otherwise, you're going to run into issues if you're using the max size of the board and you have this over a little bit, it's going to go right off the board and you're going to miss stuff. Put that down. Like 4,000 price.
Yeah.
It's so exciting to help Trevor unbox it.
Oh, yeah.
Yeah.
Because I just happened to be here in Cage that day.
So make sure that's down. I'm going to go back to its origin. I'm going to try this plan offset probing routine just to see what this does. Never mind. We're not going to do that. If you guys want to play with it, feel free, but I don't need it. So yeah, when you do your plan offset is asking how far in you want your design moved from the very edge of the PCB. I would recommend at least 2 or 3 millimeters. That way you have a little bit of playroom. Just in your X and Y. You don't need it in the Z. If you actually do it in the Z, you're likely to run into issues again with breaking bits or it not touching.
Yeah.
So once you have that set, you go next. It's going to say, okay, blah, blah, blah. Here's all the stuff. It's not letting me start it because the safety cover is not on.
Okay.
Put the safety cover on. Spindle boots. By the way, if you ever need to, there's an emergency kill switch right here.
Okay.
I've never used it, but like if it goes down and it starts grinding into the platform, I definitely recommend
Okay.
slapping
Part
it.
of it like falls over while you're doing it. That'd be a good stop. Yeah.
Yeah. So pretty much that's going to be it. You're just going to press mill all. It gives you a little thing that's saying, hey, it's going to pause and prompt you to change the tool when necessary. You just tell it okay. So pretty much it knows what's in there. It's going to start doing it. It gives you a time remaining. It's telling me this is going to take 24 minutes. In my past experience, it's usually done in about 3/4 to 50% of the time it tells you. I don't know why. At least it tells you longer.
At least it tells you longer. It's probably just accounting for in case it does take longer for whatever reason.
Yeah. Or, yeah.
And so usually if you kind of watch this, what's going to happen is it'll do one trace and then it'll move and do all the rest of the traces. And then it drops down kind of like a 3D printer. So if on that very first trace, it's touching in some parts of the board and not the others, or you're just barely seeing it kind of flick some stuff off, that's perfect.
Okay.
That is exactly what you want. You do not want it to be chunking stuff off on the very first pass. That's how you know your offset is off.
Right. Because it's trying to drill too deep, too fast, and it's just making a mess.
Yeah, like if you zoom in on that, you can kind of see how there's just a little bit of dust, but nothing like what's at the bottom. Sorry, that's very hard to see on video.
Yeah, it's very, as far as my thing will zoom in.
But yeah, it pretty much just runs itself. And once it's, like I said, once it's done with one tool, it will stop, it'll rehome itself. It'll say, ready for the next tool. You take out the tool, you swap it, you put the safety cover back on, tell the program continue. If you have a third tool selected, once it's finished with that second tool, it will go into the third. And once it's finished with the third, I think it goes to the origin. It may come to the homing position, but remember, homing is where you take it off. So if you ever aren't in the home, you can just go to jog and set it to home. But once it's done, you pretty much would just lift off your entire PCB and you're set from there. If you did what I did and you turned off the traces or the outline, you're going to have to cut it off that board or just have a bunch of extra copper around your circuit. If you have outlines on, it will carve it all the way down to that base layer. So once you pull it off, it pretty much just snaps right off. Very nice. It's actually a really simplistic machine to use. As long as you have your board file ready
Right.
and you kind of have a general sense of measuring.
Right.
You're
And
set.
you get the measurements of the board all right, and you get, you've got it all lined up correctly. You got the right bit in there.
To get every measurement.
Yeah, so the biggest
It
thing,
just does it automatically. from there.
XYZ, do you need the thickness or do you need like dialect, like the
XY isn't, again, XY is just kind of convenient so that you can see if your design is going to overflow.
yeah.
The biggest and most important thing is that you get your Z right, which is just the copper plate, and then your Z offset, which is your copper plate plus the tape, but then you have to subtract what your copper plate is so that you know what just the thickness of the tape is. So like for our case, yeah, so like for our case, the tape was 0.035 millimeters,
Right.
which is so small, but again, that could have broke the tool if I said it was double that or half that. Double that. I've seen many.
You kind of just use the same tape every time. But
Yeah,
is it actually tape that's got controlled thickness on it, or is it?
I don't know.
Okay.
From what I understand, there's very specific tape that you're supposed to buy with it.
Right.
And from what I remember with Sharper is it was literally like gluing the PCB to the thing. You had to like get a screwdriver and pry it, and we were like, we didn't want to damage it.
Right.
So I think that's why Sharper bought the
Okay,
kind
okay.
of cheaper and thinner stuff. It's kind of just whatever the department
Okay.
decides to do. But yeah, it's a real pain when it breaks. And you'll hear it break.
Uh-huh.
When it goes in and the second it starts laterally moving, you hear, and you're like, oh boy.
But you definitely wouldn't want to use something like painter's tape that's kind of like got the rough.
Yeah, you want
You need
this,
something really smooth.
And double-sided.
yeah, you want like
Yeah.
an industrial tape because that's like the most standardized
Yeah.
and I don't even know the words I'm looking for.
And
Simple.
there we have it, I guess, right?
Uniform.
Yeah, But yeah, that's literally all there is to this. This guy is going to keep chugging away for the next 23 minutes unless I cancel it.
What references do you use for this?
What?
Or what like manuals, any references or manuals or anything like that you use internet?
So from what I understand, Bantam has, because they're the creators of this tool, Bantam has the entire manual online on their website. If you ever want to just read up because I skipped through this quickly or I didn't say something and you're confused, feel free to read that. It's literally just on their website as a PCB or as a PDF. Yeah, good luck finding the software. It's kind of hard. But we will work on IT getting it built into this computer. But like I said, it works with any computer with the USB-A, not C.
And it's Bantam.
Yeah, Bantam Tools PCB milling machine
Okay.
is the full title because they have like a regular milling machine and then they have like this PCB
I will
specific.
send myself an email to send out a ticket tomorrow, and I'll put you on it too. Okay.
Like service now ticket.
What? Yeah.
And there we have it. PCB milling tutorial by Don.
Yep. If you want to really upset the printer, you can rip this off, but that's also really not safe, so don't do it. I was just kidding. But yeah, it's literally the equivalent of sending something to a 3D printer. You just kind of got to make sure you have the right file, the right setup, and it's not too hard. Is there any questions from people who are online? Did I skip over anything too quick, or does all that make sense?
Yeah, we only got Andrew, Susan, and Josh still in the Zoom call.
Well, I have this one. I have my capstone one, which I hate that word.
Susan says that it makes sense.
Sweet.
What did you hear about it?
It's
Just
Yeah,
like,
they're not
or something.
hand gauge. You have to look up the part
It's just
number.
hard, is it hard to solder or like? They look like
It's-
came from the Philippines.
so-
What was your capstone?
Here's one more thing that I forgot to mention to everyone, and this recording, please, I hope you're still watching the recording. If you have surface mount devices and through-hole devices on the same PCB, please note that the through-hole devices are going to be on the opposite side because you still have to solder to the copper on that side. So when you are designing yours, you have to know that you're specifically designing it for this machine, because say you have a surface mount IC and then you have a pinhole capacitor right next to it. If you leave that capacitor on normal, well, if you put it on backwards because you're putting it on upside down, you're gonna have a lot of issues. Now, obviously a capacitor, you can just flop the sides, but there's a lot of chips you can't do that. So just as a fair warning.
That would do a soldering workshop question.
This is like-
People know how to
It's
solder.
Yeah, it was like an SD card and an RTC IC
No, we don't do it.
on one side, and then like all of our sensors were pinhole sensors, so like you could just take them
We
off
don't
and
touch
plop
solder,
them in.
right?
So we like put them on the
Yeah,
right
that's
way,
what
and then we
I
fried them,
Yeah.
like $200 worth of boards. And we were like, great. So they got new ones, and we put them all on backwards, and it worked fine. We were like, great, that's okay, that solution.
Okay, not wanting to.
Oh, what a beautiful little trace.
That sounds so if you did, so that means that, I'm a little confused about that. So you're saying this, what does this have to do with SMB, having SMB and people on the same board?
So like,
It's one side of copper.
here,
You can't solder up plastic on the other.
let me just show you on the schematic.
But when you have SMD like that, it's all copper, right?
Yeah.
But the through-hole thing also has to be soldered to the copper. But they can't be on the surface of the copper, they have to go through the other way.
Yep.
So you have SMDs on one side and you have through-holes coming through on the other
Oh,
side.
so it's all backwards?
Yeah. So you gotta
Oh,
remember
because there's not a
that.
bottom. That's just because there's not a bottom copper, right?
Yeah, you have to understand that it's milling the copper, but the copper is on the bottom side of the circuit. So you're using through-hole pumps.
Yeah, you're right. Jeez. So this thing don't have like a ground copper?
That's the thing I was.
Well, it does, you could take the bottom side of the thing and make it all around thing.
Yeah, that's what I was.
Yeah.
Pretty much.
Yeah, Dom, when I end up printing mine, I might drag you back in here to get the make sure I'm doing it right.
All good.
Yeah, if I can't think of it, I'll just come back with it. I would like to pick it up, so we can use it for later. But then it's like, I'm gonna have to like double, triple check that I'm not gonna break this $1,000 thing.
I mean, like, it seems like the main issue is the potential for breaking bits,
Which is just, that's not even part of your drill file or your drill file. It's just
Right.
setting it up, right?
And the bits are relative, it's not the $4,000 part of the machine. It's probably a couple
Yeah,
bucks a piece.
I think I got some sort of my some a single project. Yeah, right. One day you're just like, oh, really?
Oh, my capstone was quite literally me and 3 other people who rejected these files. So I was so
Oh, that,
to say the
the
least.
classic of that is they built a submersible robot for a competition like at MIT. And NAU got the whole thing together and was actually working in 1 year, and everyone else had 6 years to work on it. Now there's 6 mechanical engineers working on this project.
Oh, is this the submersible float story?
Yeah, and the mechanical engineers literally went to Home Depot, bought a PVC pipe, bought some end caps and sealed it on. Now, the one electrical engineer on this program spent his entire semester living in the IEEE room, soldering all the control modules and H bridges and everything together and doing most of the programming. There was one guy who kind of helped out with the programming a little bit, doing most for this entire robot. And the other guys built the two.
That is exactly why I'm doing EE capstone, not
Yeah.
ETR capstone, so I don't get through mechanical.
I
engineers who
yeah.
don't know- who are like,
I
yeah.
would have wished I did the EGR capstone. Really? I literally, okay, so I had two partners who all they did all semester was buy a box from Home Depot and install a freaking fan in it. That's all they did.
Okay,
So the
And we never
laptop
applied the
box,
fan. There's not even
the box that sits on your lap. That was no project,
That is
no.
So that sounds like some mechanical engineer EDR.
okay,
It was like that, and I had the two of them, and then one of the group who got mad at their guy because he wasn't doing anything.
Right.
So he sent him to my group, and then he didn't even show up to the meeting. So he was like the least useful of
How's
the
that
other
allowed?
two.
okay, hear me out
How
on
is that
this.
even allowed?
Not my group. My group's great. I love them. But a friend of mine is in a group where one of his members
What?
doesn't know how to open Google Drive. He doesn't know what Google Drive
Yeah,
is.
that's the,
That
you can't
is
figure out how to
awesome.
solve the Google Drive problem.
No. Like,
I know that was-
legit
There
emailed the
wasn't
team,
last
like,
year, but I think it was.
how do you access, what is Google Drive? How do you access
To
it?
put in a reference,
It's blocked in my
my,
company.
one of my capstone group members
Yeah.
said to me, I kid you not, the group member said to me, can I pay my friend to write the code for our project? And I said, are you kidding? Do you know what plagiarism is?
You know what?
And do you know how capstone works?
Academic integrity is.
He was like, well, we don't know how to write a.
But I mean, if you got, it would be okay if you got your friend to explain to you how to write the code.
Yes.
That would be a wonderful
I
thing.
told him like we could take the theories and concepts and we could
Right.
change it and figure it out our
Right.
own way, but like we can't just have him do it and then upload it. Like
Right.
that's so cheating.
Okay, that makes me feel a lot better just about like being an engineering grad, like student when you graduate, because I know there's gonna be kids like that who really just don't care.
Yeah. It blew my, I was nice to them all semester, I gave them good reviews all semester. It was like the final review and I was like, I literally gave one kid 2 out of 200 points.
Mhm.
We stopped recording. No, that is not good.
I don't know.
I don't have a charger.
Oh, that's your laptop?
Yeah. I have a Surface though, so if you have your charger.
I've got a
I have
USB-C
I have
charger.
a Surface charger.
Oh, yeah.
Yeah.
Oh, that'd be so useful.
Okay.
It's the magnetic one. So
We
yeah,
stopped
it's
recording at this
like
point.
that.
Sweet.
Probably.
I lent my friend my charger one time. Because it had
So long, everyone.
These are expensive.
Okay.
it had a USB port on it. So I was like, yeah, take the charger. Like, just give me